Hey bloggers, sorry about that interruption. That was Mr. Alvarez on the phone checking in with me, but it's all okay now. So here we go. Let's see if we can get to the next part. All right, so outliers, identifying outliers. So in that first video, I mentioned that we'd like to use the median value rather than the mean if the data is not symmetrical. And an example of that was if you were talking about household income, and most people in a neighborhood make like around $100,000 as their household income, but you have one billionaire living in that neighborhood, that billionaire is going to throw off the mean. So the median would be a better measure to use. So what though if we decide, you know what, that billionaire really just doesn't belong? How can we throw him out? So if we have somebody who really just doesn't seem to belong in our data set, we call them an outlier. Their data value is like so far different from everybody else's that we really shouldn't even pay attention to it. So we need to have a mathematical way of testing to see if something is an outlier. Is that billionaire really an outlier, or is he just kind of richer than everybody, or is he really mathematically considered an outlier? Okay, so an outlier is any data item located 1.5 times the IQR above Q3 or 1.5 times the IQR below Q1. So there's actually a mathematical test to determine if something is statistically an outlier. So it's not just a matter of opinion. You can't just say, I think they're an outlier, therefore they are. No, we actually test it mathematically. So in order to do this, we need to find these things. We need to find the IQR. And in order to find the IQR, we need to find the upper quartile. That's the same thing as Q3. So when it says upper quartile, that's Q3. And the lower quartile, which is Q1. And then we can test our data to see if it is an outlier or not. So let's see. So we're going to use our calculator to get the 5-number summary and then draw a box plot for the following data. So I'm going to go ahead and grab my calculator and I probably have stuff in here. There we go. Okay, so I'm going to enter this in. You can fast forward right now while I enter this in. 3, 7, 8, 8, 5, 9, 10, 12, 14, 7, 1, 3, 8, 16, 8, 6, 9, 10, 13, 7. Okay, so now I am going to stat calculate, and I just have stuff in list 1. Sorry, I'm not showing my calculator very well, am I? So I just entered in all the data into list 1. Now I'm going to get my list of statistics. So I have that my minimum value is 20. What? Did I read that right? Oh, sorry, that was the number of data items is 20. So let's make sure, do I really have 20? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Good. So hopefully I have everything in there. It says the minimum is a 1. And there it is. There's my minimum. So that makes sense. My Q1 is 6.5. And then if I scroll down, I get my median is 8. My Q3 is 10. And my maximum is 16. Okay, so now I need to find the interquartile range because that's what I need to determine if something is an outlier. So I'm going to find my interquartile range. So that's Q3 minus Q1. So that would be 10 minus 6.5, which gives me 3.5. So there's my IQR. My IQR is 3.5. 3.5 is my IQR. That I'm now going to use to figure out where is the upper boundary for my quartiles, for my outliers. Okay, so to do the upper boundary, I am going to take the upper quartile, so the upper quartile is Q3, so that's 10. And I'm going to add 1.5 times the IQR. Okay, so if I do that, I'm going to go ahead and just use my calculator, because I'm lazy like that. 10 plus 1.5 times 3.5. So I just put the whole thing in, and I get 15.25. So my upper boundary is equal to 15.25. So that means any number that's bigger than 15.25 is going to be an outlier. So any value above this is considered an outlier. So any value above 15.25 is an outlier. It is a statistical outlier. It is far enough away from the median to be considered strange. So do I have any values that are above 15.25? So if I look at my list above 15.25, yeah, the 16. So this 16 here is an outlier. So I've done my test and I've determined that the number 16 is an outlier. That data value is an outlier. Okay, now we're going to test the lower boundary, see if we have any numbers that are too small. So my lower boundary, can we see what I'm writing? Lower boundary. Same idea. It's going to be the lower quartile, but this time, oops, sorry, I didn't copy the equation here. I just borrowed it from up here. Sorry, I should have done that. Now I feel bad. This was Q3 plus 1.5 times the IQR. Sorry, I should have been paying more attention. I should have written the equation first. Okay, I'm going to write the equation here for the lower boundary. So this is going to be Q1 minus, because if it's too small, it's going to be to the left of Q1, minus 1.5 times the IQR. Okay, so if I set that up, my Q1 is 6.5 minus 1.5 times my IQR is still 3.5. Now I'm going to put that into my calculator to get my lower boundary. So 6.5 minus 1.5 times 3.5 gives me 1.25. So this equals 1.25. So that means any value below that will be an outlier. So any value below 1.25 is an outlier. All right, so do we have any data values that are below 1.25? So if we look back at our list, do I have anything that's below 1.25? Yes, I have this number 1. So this one is an outlier on the bottom end, on the lower end. So the number 1, that data item is an outlier. Okay, oops, is an outlier. So we are going to, oh, I was supposed to do that here. Sorry, that was the test for outliers. Bam, just did it. That was the test. Here's my test. Test for outliers. Okay, this is my test for outliers right here. That should have been up here. Okay, so now we're actually going to make a box plot. See, I had the other part of the paper down here and I kind of messed up, but that's okay. So we're going to make a box plot, and I am going to actually do it down here because I wanted to use the graph paper. I wanted to have this here. Oh, I'm so messed up, but that's okay. Please forgive me. All right, so I'm going to make a box plot. So my numbers, my minimum was 1. If I look back up here, zoom out, my minimum value is 1 and my maximum is 16. So I'm going to set up my number line going from 1 to 16. So I'm going to do it down here. I have plenty of space. So setting up a number line. And I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Is that far enough? Yeah, I only needed to go to 16, so let me back off on that. Okay, now I'm going to put on here my outliers. So what I'm going to do is I'm first going to plot my outliers. So I'm going to plot outliers as asterisks. I'm going to use an asterisk. Okay, so my 1 I determined was an outlier. So I'm going to have a little asterisk at 1. And then I also determined that 16 was an outlier. Okay, on the upper end, we determined that 16 was an outlier. So I'm going to put a little asterisk at 16. That's how I show my outliers. Okay, now to do the rest of the box plot, since I took out the minimum and the maximum, those are our outliers, we now need to use the next smallest number. Okay, we can't use the minimum and the maximum to be the ends of our whiskers. Instead, we need the next smallest number. So if I had a big data set, I would actually go back to my calculator and I would sort my data. I'm going to go ahead and sort it. So I'm going to sort list 1. So I will go back and look at it. So the next smallest number after a 1 is a 3. I probably could have figured that out here as well. So now I'm going to plot the next smallest number. So when I do this, I'm going to actually put a closed dot. I'm going to put a closed dot. So this is the next smallest number. So the outliers are with an X, with an asterisk. And then I'm going to use the next smallest number. Use the next smallest number. And then, of course, on the other side, I'm going to use the next biggest number. For the whiskers. Okay. All right, so what was the next smallest number? Again, I can go to my sorted list, see after 16, what was my next smallest? The next smallest was a 14. So I'm going to put a dot at 14. And then I do my Q1, my median, and my Q3 like normal. So my Q1 was 6.5. That would be right here. My median was 8. That would be right here. And my Q3 was 10. That would be right here. And let's go ahead and try and make that a little cleaner. Make my box and my whiskers. There it is. Okay, so now we can also do this on our graphing calculator. So just like we could make a box and whisker, or rather a box plot, whatever we want to call it, on using our stat plot, we can do that with this one too. So some of you have already seen this. If I go to stat plot and I select the first one and I'm going to turn it on, notice in here there is a scatter plot, okay, a line graph, histogram, and then there's 2 box plots. There's 2 box plots. One of them has extra little dots. That's the one that has outliers. So I'm going to select that. And then I have an X list. I do not have a frequency list, so I want to make sure I take that out. And notice the mark, that's I think for the outliers. Let's see what happens. I'm not sure. So let's go ahead and look at that. To look at it, to make sure it goes into a good window, remember we do zoom 9. Uh-oh, what happened? What happens if I just graph it? Oh my gosh, what happened? Should have tested this out. Oh, I have stuff in here. I wonder if that's doing it. Okay, let's try it again. Zoom 9. Shoot. How about zoom 6? Oh my goodness gracious. I hate it when stuff happens like this. Quit. Stat plot. Let's go back to stat plot. What is going on? That's on. Oh, I wanted to take that out. Maybe that's the problem. Let's see. Zoom 9. No. All right. Okay, obviously I'm going to have to take a break and figure this out. Usually what happens is I take a break and I figure it out instantly. So let's see if I have good luck. All right, I'm going to look into this. I'll be back.